The Young Structural Engineers International Design Competition, YSEIDC, challenges young engineers from around the world to test their ingenuity, imagination, and inventiveness, and apply their design skills to solve an engineering problem. The competition is held every 3 years. In 2020, young engineers were asked to design a sustainable habitat for coastal communities from least developed countries who face the prospect of rising sea levels due to climate change. Our winners will explain more about the brief shortly. There are 3 prizes awarded by the judges. This evening we will be hearing from the overall competition winners who were awarded the John Barrett Prize. The prize was established by Anne Barrett to honour the life and work of her late husband John, a member of the institution who was keen to develop design skills in young engineers. We are very grateful to John Barrett's family for their continued support. We also have 2 YSEIDC judges with us this evening, Shalini and Tom Newbury, who will be giving us their perspective on the winning entry. Welcome to you both, and we'll hear from you later. So, without further ado, I'd like to introduce our winners, Suista Gurung and Carlo Cabanas. Suista is a structural engineer at London Structures Lab and graduated with her M.Eng from the University of Surrey. She's interested in sustainable design, climate change challenges, and female empowerment in engineering. Gian is a structural engineer who is currently working at Elliott Wood Partnership and graduated at the University of Surrey. He has a keen interest for sustainable design, humanitarian engineering, and social housing. Welcome to you both.
Hi everyone, I'm Suista and this is Carlo. Before we start, we'd just like to say a massive thank you to the team for organising this event and just giving us this opportunity to share our design. So more about the brief. So the brief consisted the challenge was to really design a village for 100 residents in a least developed country that was at the risk of flooding and sea level rise. And with the submission, we had a A1 poster, essays discussing our various options, and our research report as well.
So when we were researching for a suitable country, we looked at the list of the 46 LDCs that are currently in the world, and we shortlisted countries based on the areas that had low-lying coastal regions. So after doing some research, we discovered that Bangladesh had challenges not just from a flooding perspective, but also from an urban development perspective. The country has a rapidly growing population and has significant challenges with regards to urbanization, unplanned city development, and the prevalence of informal settlements in these cities. Bangladesh also has significant geographical challenges. The country is currently located at the confluence of 3 large river systems, the Ganges River, the Brahmaputra River, and the Meghna River. And it's essentially a large river delta that is subject to seasonal and frequent flooding. So coupling with these pressures with climate change, it's predicted that by the end of the century, a 1.5 meter rise in sea levels will result in 17% of the country being underwater, which would displace about 50 million people in the country. So with this research in mind, we felt that Bangladesh would be a suitable place to base the project on. And then delving a bit deeper, we tried to find a suitable site. And to do this, we looked into some case studies, and we stumbled upon the case study of Polder 32 in the southwest region of the country. This area adopted the Dutch polder and dike system, which has been used in Bangladesh since the 1960s. And the system is basically an embankment system that protects the land against flooding. But this hard engineering solution was successful in the Netherlands. But as evident in Polder 32 and around Bangladesh, foreign consultants failed to consider the impacts of sediment. The rivers of Bangladesh, unlike the rivers of Europe, actually carry 1.2 billion tons of sediment per year. And this causes a large amount of silt to be built up on the riverbed. And in the end, this poldering solution was actually a failure, and it actually increased the flood level. So learning from Polder 32, many people in Bangladesh are going back to traditional techniques whereby they allow the land to naturally flood. And this is something that we wanted to incorporate into our design.
Yeah, so as Gian mentioned, we focused in the area of Polder 32. So this community was significantly impacted by Cyclone Isla in 2009, mainly due to the 4-meter embankments of the Polder system failing, leaving the community completely submerged by waves, with further long-term impacts due to the buildup of stagnant water, due to also the absence of any mechanical pumps. This southwest region is said to already be sinking at rates of 9 millimeters per year, making it very vulnerable to seawater flooding, with additional factors such as erosion causing the area to sink 1 meter over the course of just 5 years. So all of these factors have resulted in the displacement of these communities, with many having to relocate to other polders or even informal settlements in the city. Therefore, throughout our design, we had to think about how we could retain these communities in these rural areas to prevent further pressures on cities and also to mitigate disputes between communities. So then, taking these into consideration, we developed our design philosophy to focus on people, progress, and the planet. So this was really about ensuring that the needs and the wants of the people in the community were met. We wanted to encourage progress of the community through building on their existing traditional skills and knowledge, and as well as designing for long-term sustainability. So thinking of all these different concepts, we developed a criteria that focused on cost, materiality, resilience, buildability, and acceptability. So kind of briefly expanding on each of these, cost, we focused on the methods of reducing cost of construction, maintenance, and making comparisons to traditional alternatives. In terms of materiality, we wanted to really understand the vernacular architecture and historical methods to gain insight into the locally available materials, to not only mitigate the transportation emissions, but also to promote local businesses and self-recovery. In terms of resilience, we wanted the design to efficiently adapt and respond to changing conditions while still maintaining functionality, even at predicted levels of flooding. Buildability, we looked into focusing on modularity at various macro to micro scale, which allows for an ease of expansion. And in terms of acceptability, it was important for us that the design would complement the culture, tradition, and livelihood of the people. So then when we started brainstorming different ideas, we were pulling inspiration from existing settlements around the world. And we developed 3 main ideas. So for option 1, we were inspired by the Uros floating islands in Peru, and coupling this with the modern prefabricated expanded polystyrene concrete platforms, we designed this floating village. This was really cost-driven, as these platforms require quite minimal maintenance. But after considering this option, we really felt that it was completely disregarding how the indigenous people lived. It didn't make use of the existing land area. And there were also major kind of concerns for the impact that the design would have on the river. In option 2, we looked at a shipping container community. So these homes would be at ground level and adapt to the flood levels using the plastic float platform stored below ground. It's quite interesting because during our research, we learnt that there was a massive shipyard located south of the country in Chittagong. So this design was not only just to, I suppose, provide homes for the community, but it would also give us the opportunity to possibly upcycle these shipping containers that were nearby. But again, this option, similar to option 1, wasn't really complementing the traditional architecture. It would make self-recovery very difficult, and there were a very limited guarantee that the shipping containers would be of required quality. So then finally, we looked to develop option 3, which was the adaptive bamboo village. So taking inspiration from stilt villages in Asia and Africa, such as the Tayo village in Lantau, Hong Kong, as you see in the image, we wanted to design something that would be prepared for embankment breakage and to ensure that the livelihood and the functionality of the community would not be compromised. So we wanted to highlight the use of local materials here, local architecture, and so that the residents would actually want to live there. So kind of talking more about this, we started looking at the local vernacular architecture that influenced these rural areas. And we found that the architecture actually even varied from division to division and was heavily influenced not only by the local materials available, but also cultural differences and local hazards that they were exposed to. So for example, in the image, you can see some divisions were characterized by clay roofs and clay steps, while others were built on stone. So looking at each option, we started to map out where each of the materials would be coming from to get a better idea of the carbon associated in terms of mainly to do with transportation. And it was really kind of helpful for us to visualize clearly the impact that each of them would have. For example, even though we wanted to upcycle the shipping containers from Chittagong, other required aspects of option 2, such as the plastic floats, would have to be shipped all the way from China. So beyond just, I suppose, the carbon aspect of it, it would also make it really difficult for the community to expand on its own. So this was a very important exercise for us to go through in our design. And then finally, another major influence was our own personal experience and knowledge. Gian and I started a research group called Bamboo for Better in our final year at university. And through it, we got the opportunity to really explore the bamboo industry and design in the Philippines. So we wanted to take our understanding of the material and adapt it to suit Bangladesh, as it's a material that is quite widely available in the country.
So building on this research, and just to give you a brief overview of why bamboo is such a good material. Firstly, it's a bio-based and highly renewable material, and it's one of the most fast-growing plants in the world. It has a very low embodied carbon of only 0.87 kilograms of CO2 per meter length. And this is if you disregard the carbon sequestered, which would decrease this number. It also has a very high strength to weight ratio due to its hollow cylindrical form, and this makes it suitable for long span structures. The material is very cost effective and is locally available in Bangladesh, with 7 species of bamboo currently suitable for construction and currently grows there. The bamboo plant itself also has numerous ecological benefits, and bamboo forests can act as natural ways to reduce erosion, to stabilize soil, and to stabilize the water cycle. However, it's still a very underutilized resource, as many people perceive the material as a poor man's timber. And this is despite many vernacular techniques being developed over the years in Bangladesh and around the world. So for this project, we decided to try and change this and to create a village and a new industry that is centered around bamboo and agriculture. So we came up with this village layout, which is designed around agriculture. The village is split into several zones. So on the right, as you can see, is farmland, and this farmland will be raised above the flood level using earth embankments. And these embankments will be stabilized by a bamboo forest, and this forest is designed so that it will be regularly harvested and be used by the villagers to actually grow the village. The farms will comprise of a variety of different food crops and focus on a more regenerative model of agriculture. And this will ensure that the soil stays nutrient rich, and so that many different crops can be grown throughout the year and provide a sustainable supply of agricultural produce. Then you have the industrial zone where these crops will be processed, and then in the middle you have the market and the community center where all the agricultural produce will be sold. And finally, you've got a residential zone and the foul water treatment zone, which will also be raised on embankments. And tying all these zones together will be these elevated walkways, which will be the main access route for the villagers, both during the dry and the wet season.
So yeah, during the dry season, the village acts as a typical Bangladeshi village, with the market being the focal point, with the market in the middle of the village square. Many activities can take place around and through it. So during the dry season, people can walk around at the ground level, but can still utilize the elevated walkways as access routes. And each individual houses are centered around communal courtyards, so that the residents can interact with one another. And as our name suggests, the design is focused on ensuring that the village would be able to adapt during the wet season and still enable the community to function as normal. So, as Gian mentioned previously, the locals, in the past have allowed the land to flood during wet season. Taking this, we've designed the ground floor to be able to flood for up to levels of 2 meters above ground level. And this is possible, and the full functionality aspect is possible through the use of our adaptive wall-to-raft system, as well as the elevated walkway, which will allow people and goods to move through it no matter what season it is.
So talking more about the individual buildings themselves and the structural design, we wanted to make the buildings to be as cost effective as possible. And to do this, we opted for a modular, adaptable and prefabricated solution. As we're allowing the ground floor to flood, we had to create a 2-story building to avoid the floodwaters. And as bamboo will actually rot when exposed to water for a long period of time, we had to create the structural grid to be of a reinforced concrete construction. So we've got this 3x4 meter structural frame that will support a mainly bamboo first floor structure. Now the first floor, to protect the bamboo against elements and to provide longevity and disaster resilience, we opted for this Baharake system of shear walls, which is similar to a wattle and daub system. And here it's just like a thin layer of mortar that will sort of protect the bamboo and allow for composite action. And this is something that we actually discovered in the Philippines, and it provides significant disaster resilience. And then the innovation in this design is actually when it's the wet season. So we have these foldable stairs and foldable windows, and also this removable wall to floating raft system that we'll touch upon later. And finally, you've also got these bamboo levers to allow for improved air circulation, and rainwater harvesting will be utilized wherever possible. So a family house during the dry season will sort of look like this. You can see that the ground floor space will comprise mainly of flexible living and storage space, and there will be a semi-outdoor terrace with a rammed earth floor. The bedroom, the living area, the bathroom and the kitchen will all be located on the first floor level, and this is designed to avoid the floodwaters. And then you have this modular 3x4 grid, which is very simple, and it means that residents can expand their houses and adapt the spaces according to their needs. And then when it floods, the house is designed to completely transform and adapt. The ground floor walls can turn into these floating rafts, and the stairs can fold up into themselves to avoid the floodwaters. So although the ground floor space is lost, this is regained by the floating rafts and provide a stable platform for the residents to use. So as you can see, although you lose your ground floor, you still retain your main living space, and you regain back some of the outdoor space through this floating raft system. And then the marketplace is a similar story. The market structure will comprise of a 4x6 meter RC frame, and that will support a lightweight bamboo structure for the roof. This structure will comprise of catenary bamboo arches, and this will not only showcase bamboo engineering, but it's intentionally open so that it will welcome visitors to the village, with the market acting as a gateway to the community. So during the dry season, the market will be at ground floor level and will sprawl across the surrounding courtyard, similar to how markets are in places around the world. And the first floor level will act as a multi-purpose space where villagers can gather for functions and events. And then during the wet season, the market continues to retain its function and be the focal point of the village. As the ground floor is allowed to flood, the market moves onto the first floor level, and similar to how the walls of the houses turned into bamboo rafts, these modular internal market wall partitions can be transformed to form this floating platform around the existing structure. And this floating market solution was inspired by the floating markets of the Mekong River in Vietnam. And the idea is basically for each floating bamboo raft to be its own market stall where the vendors can sell their goods. And then the last typology in this village is farm and civic buildings. And these are just basically larger versions of the houses, and they too follow a 3x4 structural grid. The intention is for the farmers to live on the first floor, and they process their goods in this large round earth courtyard in the middle. As shown in the image in the top right, these buildings will be conveniently located next to the farms so that the farmers have easy access to their crops. And then during the wet season, the farm buildings continue to function as normal, and the bamboo rafts can again be utilized to form these large interlocking floating structures. And these can be used as a stable platform to process goods and agriculture as is normally done. And then these rafts can also be used to create these floating gardens, which are prevalent all over Bangladesh. And yeah, this is something that we just discovered with our research. But yeah, so as you can see, the floating raft system is a very adaptable and can provide solutions for all different typologies in this village, from creating terraces for the houses to providing extra space for the market, and then to finally being utilized as floating farms. And I think the success of this design is not due to fancy new materials or significant innovation, but instead we try to show that we can learn and adapt traditional and local designs that local people already use as a solution for more modern problems like climate change.
So looking beyond the buildings for our foul drainage system, we decided to go with a centralized reed bed system, which we felt was a more sustainable solution to treat the foul drainage as opposed to a conventional decentralized system. Being a more natural method, it can remove up to 60 to 8% of solids, which makes it efficient and also reduces the risk of odor. And also this solution eliminated the need for any excavation works, which was in terms of cost estimations, and also the sludge that is produced at the end of the process can be reused for farmland, completing this circular flow of our master plan. So then revisiting what we mentioned right at the beginning, we always wanted this to be quite a community-centered proposal, using local materials and building on existing skills and knowledge. The simplicity of our design, I suppose, enables the ease of expansion according to the needs of the people. Through training and the idea of self-recovery, we really wanted to give the residents complete ownership of the design, which results in the empowerment of the community. So in terms of the rollout for the proposal, we decided to have 6 specific phases. So initially, we want to start growing the bamboo on the existing polder. This is not only to establish a form of income, but also because bamboo requires at least 3 years to mature enough to be used structurally. Next, we would start building some of the core embankments and the reed bed system. In phase 3, the required farming, treatment facilities and marketplace will be built. This is so that at this point, the bamboo can start to be treated and produce can really start to be sold. At this stage as well, the training of the locals on building techniques will start. This is also, I suppose, a form of reassurance and to encourage the residents that the project is long-term. Following this, the raised walkways is to be built so that in the event of a flooding occurring during this period, the bamboo farming and treatment will not be significantly impacted. Then gradually the houses will be built in neighborhoods of 5, with phase 6 completing the plan with all the remaining schools, office, civic buildings being built. So as suggested with the costs, we wanted to ensure that our design would be cheaper than traditional alternatives, and comparing it to the traditional puka houses, we found that our design was cheaper. And we also wanted to ensure that a form of, in terms of funding, we wanted to make sure, beyond funding, I suppose, we wanted to make sure that our design was really in line with what Bangladesh wants. So looking into the government initiatives, we found that the government has really been trying to encourage projects that fall into the following categories listed on the right there, with our project ultimately falling in the shelter project category. This would not only help us in terms of funding, I suppose, but also being able to have the freedom to possibly replicate the design in other similar Polder communities. So yeah, I think that's everything. We hope we've given you a good insight into our proposal. We really, enjoyed putting all of this together, and yeah, we'd just like to say a huge thank you to the iStructE for not only putting on this event, but the entire competition. And yeah, for those who are considering of getting involved in the next couple of years, we highly recommend it. So yeah, that's everything, I think.
Thank you very much, and thank you for that presentation. It was a really good presentation and really clear and really good to see. I just wanted to, so I'm one of the judges. I have a background, I'm a structural engineer, but I also have a background in emergency shelter and low-cost housing, which is why I was on the panel for this. And it was a really interesting opportunity to go through, to be a judge and look at all the proposals that came in and the entries that were made. This one for me stood out as the winner because it really got to grips with this as a process and not just an isolated technical solution. So it really, reading through the entry for this was a real pleasure, because it felt like this was something that was really for people and for a community, rather than something that was more for the benefit and the interest of the designer, which is a real risk in designing projects like this, both in hypothetical situations like a competition and in reality, that the designer's desires and wishes get imposed on a local community. And there was real consideration in this of circular and regenerative economy. It really made it stand out. And one of the tests I apply when looking at projects for low-cost housing for vulnerable communities is really, is it something I could envisage wanting to live in myself? And this one really passed that with flying colours. As well as that, it was made real and really quite realistic, because it had a very specific site, and there was such detailed research into the history and context of the chosen site that made the proposal come to life. And as well as looking at that process and thinking about how are people going to use this, and how will people live with it, and what's appropriate and what is not appropriate, it really did address some of the key technical questions in what is a really incredibly challenging problem that faces coastal communities and low-lying communities around the world. It addressed sewage and waste, water, housing, livelihoods, access to local services. So it really was quite a holistic proposal. And I really liked the phased plan for developing it, and the way it used materials and solutions in a really appropriate manner, didn't push any of the materials further than it should, and ended up with something that was genuinely feasible in the context. It's labeled rather than technology intensive, which is highly appropriate. Had a really good balance of new ideas, although those ideas were still brought from elsewhere in Southeast Asia rather than much further afield, and local practices, and that's really key for success of projects like this. So it demonstrated such a good balance between the holistic high-level design and critical structural calculations as well, to demonstrate the feasibility of the design, and you'd really chosen, what are the key calculations we need to do to demonstrate that this is going to work. And finally, it was just so extremely well and professionally presented. If the boards that you produced were put up in a real design competition, I think they'd have a high chance of winning. It was really they were very well put together, and overall the level of detail you managed to get into was truly impressive. So that's, yeah, I think you should be very proud of yourselves.
Good stuff.
Shalini, did you have anything you wanted to add?
Yes, thanks, Tom. I mean, you covered a lot of the points that we discussed as judges during this competition. There's one thing that I do want to say, and it's that from all of the submissions that we had, there was really a remarkable amount of work that was clearly put into all of the bids. I mean, into all of the submissions, which was excellent. And the part that really stood out about this one for me is that I remember I got excited during the judging panel and the discussion. I said, you know what, let's find some money and let's go do this project, because this is realistic, this can happen. I can really see it being done in a place like Bangladesh. Just considering the Polder system that they had in place, considering the livelihoods of people, their culture, their backgrounds, and how they survive on a day-to-day and how they operate on a day-to-day basis is really important. I mean, my background is, yes, I'm a structural engineer, and I also do disaster response and a lot of work in developing countries. And one of the biggest things and one of the biggest drawbacks that you have on any type of project like this is buy-in from the local community, so that the people who are actually going to use that space. So like Tom had said, where one of his biggest things is he asked himself, would I be willing to live there? And that's something that both of us, together with all the rest of the judging panel, agreed with. I mean, it's so well thought of. It was so well researched. The level of details that they put into it was clearly really a holistic project. So congratulations again to John, Karlo, and to Suista. You all did an amazing job, and it's really impressive that it was just two of you. The other things that really stood out as well is that you were able to articulate and communicate, bring your points clearly across to us and to the wider community, which I think is everyone would have seen just now from your presentation, which is really impressive, and congratulations to both of you.
Thanks, Shalini.
Well, that's brilliant. Thank you. Right, well, we've got some questions, so I suggest if we just go through and I'll field the questions, and I'll leave you to fight amongst yourselves as to who wants to answer. But first question is from Steve Brown, and he said, how did you approximate ground conditions to size the pad foundations?
So we were actually able to get hold of some borehole results, which kind of showed the ground conditions and how they changed from areas such as Khulna, which is where our site was located, as opposed to Barasal and stuff. So yeah, so we were actually lucky enough to find information on that.
That's brilliant. Okay, thank you. Edward Malarkey has said, thank you for your excellent projects and ideas. Will the reed bed system function okay in the wet season when it's flooded?
I guess that will depend with the design, but I guess if we have enough drainage and put it in that system, it should be able to work. But I guess we just put a reed bed system in there because it's, again, a more sustainable solution than just having a big like underground drainage system.
Also,
and,
sorry. Also, we kind of forgot to mention in the design, but we do have embankment that is built around the reed bed system as well. And obviously, with these things, you know, we design it for the predicted levels of flooding in the event that it breaches that. I mean, I think that's quite difficult to really kind of reason, but you know, also its distance from, that's why we wanted a centralized system away from the community as well. So in terms of impacts of when the reed bed system, when the embankments, if the embankments are breached around the reed bed system, it wouldn't have such a significant impact on the people in the community. So yeah.
Brilliant, thank you. Sasha Nathan has said, the system juts out from the coastline a fair bit. Why is this preferable over spanning the village adjacent to the coastline? And would storm and flood risks be reduced this way?
Sorry, so in terms of the question, you mean why would we?
I think it's why did you sort of project everything directly out from the sort of high land rather than running along parallel? I guess.
I think a major thing to really consider here is that this community has displaced people. I think kind of not considering where they lived and kind of disregarding, in terms of land ownership, some of these people, this piece of land is really the only thing they own. And kind of we couldn't really justify taking a community and completely settling them in an area that they're not used to, away from their livelihoods, away from away from their culture. So yeah, I mean, that was kind of, I suppose, the main reason why we didn't completely move the community.
That's brilliant. Thank you. John said, hi, you mentioned the main material is bamboo, but the structure also uses concrete. Could you please elaborate on how bamboo and concrete can work together? So I assume he's talking about the interaction, the junction between the concrete and the bamboo structures.
Yeah, so you just basically use the concrete as the platform to build the bamboo structures on. And what you do with regards to joints is sort of you have this thing called cement mortar infill joints, where you have like a steel rod that goes into the bamboo and then you infill that. And then you have the baharake system, which is something that we found out in the Philippines. It was visited disaster resettlement sites where they've built these baharake construction. And it's basically a bamboo frame with like a cement mortar render on the outside, and it acts in composite action. So yeah, this is it's a real life solution that's been built in the Philippines, and yeah, credit to Felipe Luis to that.
Yeah, no, that's brilliant. So one of the things that I was thinking, to be honest with you, is you said in one of the earlier slides, I think, that the bamboo can rot when exposed to water for a long time. Do you have to treat it if you're using it like structurally, like we would timber here?
Yep.
Yeah.
So it's the same sort of thing, is it? You just there's just treatments to give it some rot protection.
Yeah. So the main issue with bamboo is actually this beetle, and this beetle likes the starch in the bamboo. So what you do is you have to wash the bamboo to get rid of the starch, and then you soak it in this solution. It's like selenium or boric acid solution. So it's not great for the environment, but you don't use a lot. And that is the protection that you get.
Also, I suppose the bamboo rafts, the reason we wanted the self-recovery aspect of it and building it on site was that we understand exposing these bamboo rafts on water for very long periods of times, we can't really maintain them as well. So ensuring that they're quite easy to replace and really easy to make was quite important to us as well.
Yeah. So you've done, obviously talked about research in the Philippines. What are the sort of main similarities and differences between Bangladesh and the Philippines?
I think the main similarity was people's perception. I think in a lot of these communities, they view it as, Gian mentioned, poor man's timber. And so we found even in the Philippines that you find people, not really wanting to move into these bamboo structures because even though they're better than, they can perform just as well, they don't like the perception that they hold towards bamboo structure. So we found that quite similar, and I suppose the history with using the material and similar techniques. In terms of the main difference was really the species of bamboo that you find in the varying countries.
Brilliant. So John has said, great presentation from the both of you. Well, I think we can all agree with that. Congratulations on winning. How did you both get into bamboo design?
Yeah, I mean, credit to my lecturer at I did it for my dissertation in my third year, and it was just something that I noticed a lot in the Philippines. You have these bamboo structures that aren't built properly, or like just, there's better ways of doing it. So yeah, I did a dissertation on bamboo joints, and then in my final year, I continued doing research into it, and then I brought Suista in, and we did like this research into, because her interest is social housing, so it sort of ties the material sort of ties up all our interests together. And then we won a research grant to go to the Philippines and do some more research. So I guess it wasn't really like I want to do bamboo. It just sort of fell into place from university and carried on to work.
We just thought, you know, there's so much in terms of the architectural aspect of it. There's quite a lot of content that you can really look through. You can see all of these beautiful bamboo structures in Bali, and you know, obviously they're extremely fascinating, but we kind of wanted to see how this material could be used for you know, cheaper disaster projects. So yeah, and then looking more into it, bamboo was a material that kept, I suppose, popping up, and yeah, that's where the interest started. Yeah,
fantastic. We've got Ali from University of Surrey here, which says, what is the next step for Bamboo for Better? So I'm assuming Bamboo for Better means something to both of you.
Yeah, it's the research project that we started, sort of like a focus group on bamboo. And Ali was my lecturer who got me into bamboo. So hi, Ali. But yeah, I guess the next steps is just to continue doing projects like this and hopefully start building stuff. We've got a few things happening in the Philippines and Nepal. But yeah, just sort of to keep pushing the agenda for more sustainable solutions using bamboo.
Fantastic. Right, just a couple more I think we've got time for. Navid has asked, you proposed the walls to be used as floating occupied platform, but what is the acceptable loading on these? One layer of bamboo grid seems incapable of carrying a significant load while staying afloat. So I guess it's how much can you get on one of your little bamboo rafts, isn't it?
Yeah, we did some buoyancy calcs. So we've got, I think, 4 layers of bamboo in there, and that can carry about 1.5 kilonewtons per meter squared, which is not significant, but it's enough for the function that we intend it to be.
Yeah,
I mean, that's a decent load, really. It's enough for most sort of normal uses, isn't it?
And if you just sorry,
and also these rafts, you know, they're not really, people won't be really using them for long periods of time. Like we said, it's either kind of movement to places or regaining outdoor space where people would occasionally go, or else we have the elevated walkway or the actual the first level where people will actually be living.
Yeah, and if you want to increase its buoyancy, you basically just add a few more layers of bamboo, and it will float.
Perfect. I'm sorry, we're still going here. So Alexander has asked, well, congratulations and thanks for the presentation. How do you provide fire resistance when using bamboo?
So in terms of the in terms of the treatment process, kind of in the Philippines, they provide a level of fire protection. Unfortunately, we can't kind of completely guarantee it, but because in the actual structures, because they're encased, so the bamboo itself isn't exposed entirely. So because the bamboo itself is encased, it kind of increases the fire protection of them. But yeah.
Lovely. You've obviously had a good influence, because Rona Reed has asked, where can we find out more about your research project, Bamboo for Better?
Yeah, on Instagram.
Yeah, on Instagram at Bamboo for Better. Yeah, that's our kind of main place. We have links from there to the kind of research that we did in the Philippines and some of the articles that we did on there as well.
Brilliant. And I believe the final question we have, well, it was a minute ago. There's one more after this. This is from Ryan, and he asks, were any considerations given to alternative materials over the modular reinforced concrete frame?
We looked at like rammed earth solutions, but we found that rammed earth is not really waterproof, and to make it waterproof, you add loads of cement to it, which just makes it concrete. So yeah, I mean, concrete's a great material when used properly, and there are ways to reduce its embodied carbon. So we looked in the area, and there are a few like concrete processing plants, so that reduces your carbon due to transportation. So yeah, I think for this project we couldn't entirely remove concrete in the process in the design, because you're allowing the ground floor to flood. But yeah, we did look into it.
Fantastic. The last question we have at the moment is, this is probably going to catch you, this one. How do you supply water and electricity, especially during the wet season?
So we obviously didn't mention it in this presentation, but we have it on our poster. But the water and the electricity lines will actually be elevated at the raised walkway level, so in terms of flooding, it won't be impacted. But also we plan on having decentralized rainwater harvesting systems in each of the houses as well, to be able to to supply more water.